Hey guys, this is Janie back at it again, and today we're doing 11.4 rational functions, and again we are going to use functions modeling change, preparation for calculus, 4th edition for our lesson today. So let's get right into it. So, what is a rational function? Well, if we take a look at this blue box here, it will tell us that if r can be written as the ratio of polynomial functions px and qx, that is, if rx equals px over qx, then r is called a rational function. So it's basically saying if two polynomial functions are divided by each other, that is a rational function. But one thing we have to take into notice here, and that is very important, is that we assume that qx, the denominator, is not a constant polynomial, saying that qx can't be something, for example, like 5 or 3 or something like this, because if it is, then this isn't a rational function because it's just one polynomial function, so it'll just be a polynomial function rather than a rational function. So qx, the denominator, cannot be a constant polynomial, and it cannot be 0 either, because then it will be undefined. And also, it doesn't say here, but px also cannot equal 0, because that would just be 0, and rx would just be 0, and that isn't a rational function because we just said it's the ratio of two polynomial functions, px over qx. So yeah, that is a rational function. So when we take a look at rational functions, one thing that we also take a look at is the long-run behavior of rational functions. This is actually what we've been doing before in polynomial functions, and it is actually the same. So for every rational function, it's going to behave like a power function eventually in the long run. So that's pretty much the same like a polynomial function. And how do we define that? We're going to take a look at the leading terms of both the denominator and the numerator. For this case, in the numerator, it's the fourth power, and in the denominator, it's the second power. So we're only going to take those two and then divide them, and this is our result. So basically, in the long run, this rational function is going to behave like this function, like this power function. So normally, this would be fx, but in the long run, it's going to behave like a power function like this. Because it's positive even, it's going to behave like a positive even power function. So that's basically what it's saying. So just the thing that you need to remember is that, number one, take the leading terms. Sorry for this being slow, but yeah, take the leading terms. And remember that it's going to behave just like a power function. So if you know your power functions and how they act for even, positive, even, odd, and all those, then you'll be able to know how every rational function will behave in a long-run behavior. Last but not least, we're going to take a look at asymptotes for both horizontal and vertical. So this is kind of a long description, but if you just take a look at the key points, so basically, if you want a vertical asymptote or a horizontal asymptote, either the numerator has to equal 0 or the denominator has to equal 0. So for example, if we want a vertical asymptote, then the denominator must equal 0. And they give us an example like this. Since this, oh no, this is an example. This is an example where there isn't a vertical asymptote. But if we want an example where there is a vertical asymptote, it can just be something like f, okay, wait. Okay, so let's say we have a polynomial function like this. This basically, we know that it equals 0 because if we put x minus 3 equals 0, we get x equals 3. So x equals 3 will be your vertical asymptote. But if we take a look at this one, this will never equal 0 because if you put it as 3, it's always going to be bigger or the same as 3. X squared can never be negative, or it can never be a negative that is bigger than 3, so we know that the graph is going to look like this, and there is no vertical asymptote anywhere. So if you want a vertical asymptote, we have to try to put it as 0, and if there is none, then there is no vertical asymptote. Okay, so that was 11.4 rational functions. I hope you got that, and I will see you in our next video. Thank you.